So we completed all these ones. Functions also, I think we did. Then we completed the transformation thing as well, right?
Yeah, we did.
Chapter 2 also we already completed. Okay. So let me start with the chapter 3. This is about the coordinate geometry. So anyway, the first part would be very easy because we have done these theories earlier as well. So here for the
Yes.
coordinate geometry, if I quickly move to the theory part, why do we study these theory? Coordinate geometry. There are so many reasons why we need to study these ones. This chapter builds on the coordinate geometry work that you learned at O levels. So you shall also learn about the Cartesian equations. We already know how to write or how to build the linear equations as well as quadratic curves equations as well. So Cartesian equation of a circle. So circles are one of a collection of mathematical shapes called conics or conic sections as well. So here what will happen, a conic section is a curve obtained from the intersection of a plane with a cone. So here the three types of conic sections are, there are three types of conic sections. One is ellipse, the other one is parabola, the last one is the hyperbola. One is ellipse, the other one is parabola, and the last one is hyperbola. So the circle is a special case. Circle is kind of a special case of ellipse. So anyway, we have like four types. One is circle, the other one is ellipse, the third one is parabola, and the last one is hyperbola. These are the four different shapes of all these four curves. So here for the conic sections provide a rich source of fascinating and beautiful results so that mathematicians have been studying for thousands of years as well. So conic sections are very important in the study of astronomy. We also use their reflective properties in the design of satellite dishes, searchlights, and optical and radio telescopes as well. These are kind of few general background of the of what we are going to do and why these ones are very important clinical reasons. So now this is where we are starting the first part. So the first theory part is length of a line segment and midpoint. The first part is finding the length of a line segment and also finding the midpoint of a line. So how we do this, if I explain you how to do this, let's assume we have a line like this. This is not actually line. Let's assume this is kind of a line here.
Yeah.
We have two end points, what we called x1, y1, the first point, and x2, y2 will be the last point or the end point. To find out the midpoint is the point which we have in the middle. To find
Yeah.
out the midpoint, there what we normally do, we just add the x coordinates together and divide it by 2 to find out the midpoint of the x coordinate of the midpoint. Same as this process, we are adding the y coordinates together and divided by 2. Okay, and divided by 2 to find out the midpoint, y coordinate of the midpoint.
Okay.
That's what here we do to find out the midpoint. Since it's a midpoint, we are dividing these ones, once we add these two coordinates together, then we are dividing by 2. So that is there. Then to find out the length, what we do, we are getting the difference of these 2 points. So difference of these 2 points means if we are considering, let assume I'll put this point as A and this point as B. If we are considering this point A first, then always we should consider the point A as first. That means x1 minus x2 squared, x1 minus x2 squared plus the difference will be y1 minus y2 squared. We have to add these two together and take the square root to find out the length of PQ. But you know, when we calculate the length, we are getting two answers. One for positive, the other one is for negative. So there we have
Yeah.
to take only the positive answer as the final answer because the length cannot be a negative value. We are
Yes.
neglecting the negative answer. We only consider the positive answer as the length. That's what here we do. That was theory part. It's clear, right?
Yeah.
Okay, so O level, you learned how to find the midpoint M of the line segment, joining the points, these two, and the length of the line segment PQ using the two formula. In key point 3.1, you need to know how to apply these formulas to solve these problems as well. Okay, can you work on these worked examples? 3.1.
Okay.
Yeah, only the examples. So the exercises you can do it at home leisurely.
Okay. So how was Christmas, teacher?
I'm not celebrating Christmas Day. I got some actually Christmas treats, but
Uh-huh.
normally I have a friend in Nigambo. We are having kind of
Ah,
party there, but this time they were not here. They are in Qatar because of that, and also they came early before the Christmas. They came and went. Babeke first let
uh-huh.
එයාගේ බබාගේ first letter reading එක තිබ්බා. So they came early and went back. So this time I don't have any party to go.
Okay.
හැබැයි ඉතින් ඒක නිකම්ම ගියා වගේ නේද? There's nothing much
Yeah.
there.
Yeah.
Every days are weekdays, no. People are still working because on the January 31st and the first of, sorry, December 31st and the Jan 1st also again, again weekdays, ne. So I think
Yes.
busy with work.
Mm. So did you said that you're having your wedding next month, right?
Yes, next month. I'll be taking
Ah.
kind of a leave from 15 to maybe it's again if 15th to 20, those 5 days I'll be taking leave, so
Ah.
we can cover,
Okay, no problem, teacher.
yeah, we can cover those ones earlier before that. That's totally fine. 1 week.
Yeah, that's fine, teacher. Yeah. So when's your wedding? Like in the middle?
Yeah, January 17th, the
Ah,
third week.
okay.
I think it's a Friday, third week of Jan. 17th.
Ah, okay. Okay.
When is your results are coming? So it's, I think, like
Uh,
months, right? 3 months to 6 months. I could.
no, January 16th.
They're releasing the marks, right? That means three.
Yes. I'll be getting the hard copy in March. The
Hard
hard
copy
copy.
in March. Okay.
Okay, teacher, done.
Okay, these ones are done. So the 3.1 also done. There's nothing much, no? Then what about
Yeah.
3?
Yeah, that's also fine,
That's
teacher.
also fine. Then 3.3 also again, the distance between 2 points. Anyway, here only thing is they have given those 2 points with A. So you have to build an equation and equalize that equation to 17 and find out the value for A.
Yes.
But here also we have to do. Okay, can you do the explore 3.1 part?
Okay.
So that means you have to provide the reasons why, whether their claim is true or not. Tamar says that this triangle is all right angle triangle. So you need
So here we can use trigonometry, right?
trigonometry.
Then say
Trigonometry or else, no, trigonometry or else you can check whether
Pythagoras.
yeah, square root of these two
Yeah.
is equals to the square root of the height length kilo. You can check that one and provide the.
No, it's not true.
Yes, it's not true. That's also fine. Okay. නෑ නෑ එහෙම නෙමෙයි මං කියන්නේ. Okay, so then that is it. So this one you can do anyway. Okay, the last question, the 12th one, practice one. In triangle ABC, the midpoints of the sides AB, BC, and AC are 1, 4, 2, 0, and minus 4, 1 respectively. Find the coordinates of point ABC. Do the 12th one only.
Okay. Okay, teacher. Done.
Okay, no questions, right? You were able to identify. Okay,
Yeah.
now the next part is the parallel and the perpendicular lines. For the parallel and the perpendicular lines, if two lines are parallel, that means the gradient of these two lines are equal. That's what we call the parallel lines. So for the perpendicular lines, now what we'll have, let's assume we have the gradient of this line as m, and if we have the gradient of this line as this one as m1, this one as m2, then if these two are perpendicular, then the multiplication of these two gradients should equals to -1. That's what here we. So if those two lines are parallel, that means their gradients are equal. M1 is equals to M2. If those two lines are perpendicular, then that means the multiplication of the gradients, the multiplication of the gradient, should equals to -1. That's what here we have. Now, we know how to find out the gradient because we already found these ones, we learned these ones. To find out the gradient, what we have to do, we have to get the difference in between y coordinates, y2 minus y1, divided by the difference of x coordinate, that is x2 minus x1. If I consider the second point or first, always we have to consider the second point. Is it clear? That's what here we have.
Yes.
To find out the gradient, if those two lines are, if lines are parallel, that means here we have the what we call the two equal gradients. If these two are perpendicular, that means multiplication of these ones are, multiplication of the gradients should equals to -1. That's what there we have. Okay, do the worked examples.
Okay, teacher.
Okay, that is done. Then okay, all the ones are completed. No, then there's no any harder questions. So the next part is equations of straight line. Anyway, this also we already know. So we can find out the equations of this straight lines in multiple ways, in multiple formats as well. One method is anyway, the equation of a straight line is y is equals to mx plus c. The other m is the gradient, c is the intercept. That is one method. So here, normally we can use these ones. We can use this format when the line is non-vertical. If the line is non-vertical, that means the gradient is anyway tan 90. Tan 90 means it's not defined. Because of that, we can't have a gradient for this y-axis, or else x is equals to 0, 1. The perfect vertical line. So yeah, if we have a line equation like this, y is equals to mx plus c, that means always that line should be a non-vertical line. Non-vertical line, and when x is equals to b, when the line is vertical, where b is the x-intercepts. Anyway, we know these ones. So here there is an alternative formula that we can use when we know the gradient of a straight line and a point on the line as well. If we know the gradient as well as we should know another point as well. So then what we can do, consider a line with gradient m. We can find out a line, consider a line with a gradient of m that passes through the known point. This point is given, the point's coordinate is x1, y1, and whose general point is p, xy as well. Now what will happen? For the gradient of AP is, for the gradient of AP is, then what will happen? Gradient is m is equals to the difference of y coordinate. So what we normally do, we mark the general coordinate, that is xy, and the given coordinate is x1, y1 as well. Then to calculate the gradient, we have to take the difference of the y coordinates divided by the difference of the x coordinate as well. Y minus y1 should divided by x minus x1. That is also equals to m. Then we can rearrange this equation according to whatever we want. That's also fine, right?
Yeah.
Okay. Can you work on the work examples?
Okay.
Yes.
Okay, teacher. Okay, teacher. Hello, teacher. Hello, teacher. Done.
Okay. You are done?
Yes, teacher. Done.
Oh. So, all the worked examples are done, right?
Yeah, done.
No questions on there. So, exercise 3C. Did you do the last PS questions, 15th and the 16th one? Do only those two?
Yes. I actually did them, teacher, since you were a
Ah,
bit
right. Okay.
late.
That's good. Okay. So
Those two were fine.
those two are fine. Then you can do the rest. Okay. Now, then we are moving to the equation of a circle. So here for the equation of a circle, what we have in this section, you will learn about the equation of a circle. So a circle is defined as the locus of all the points in a plane that are a fixed distance, that the fixed distance we call it as the radius. So the radius from a given point, that is the center. So anyway, that is the circle. Now when it circles, so in the middle point we have the center, here we have the radius. Diameter means the twice of the radius, that is this. So those ones we already know. Then the Explore 3.2, okay. Now here what they are saying, using graphing software to draw each of the following circles from your graphs, find the coordinates of the center and the radius of each circle and copy and complete the following table. They are asking us to do it from the what we call the graphing tool. Anyway, if we do it manually, for the first one, what do you think? What would be the center? By looking at this equation?
5.
No, no. Center. Center is 0, 0. Because the normal,
0, 0.
yeah, x minus 0 squared plus y minus 0 squared is equals to 5 squared. No? Then the radius is 5 and the center
Yeah.
is actually 0, 0. Now, here we
Okay.
the second equation. What do we have? The center is 2, 1. Center is 2, 1. And the radius is actually 3.
3.
So here we have the minus 3 minus 5 as for the center. And then the radius is 4. 4 squared, the minus,
Okay.
we are getting 16. That is so if we have a general formula, how the general formula we write? X minus h squared plus y minus, let's assume k or something, y minus k squared should equals to r squared. That's what we call the center and the radius. That's what we call the equation of a circle. Okay,
Okay.
that's how it is. Then what do we have? So for all these ones, we can have these values. So here we have 8 minus 6. And then here we have 0 minus 4. And here we have minus 6, 0. So all these ones we can, without graphing, without using any graphing tools, we can define or we can identify the center of these equations. So here we have 7, here we have 2, here we have 8 because the square root of these values. That's what we
Yes.
have the radius and these ones. Okay, that is done. So there's you can draw these ones by using that graphing calculator. You can put all these equations there and check whether the values are correct. If I do these ones, let me share my whole screen. So there we have graphing calculators. If I search for graphing calculator, okay, graphing calculator, then I normally use this Demos one. or the math way also fine, but it's really easy for us to use this demos one. So for this demos one, we have, let's assume the first one is x squared plus y squared, no, x squared plus y squared is equals to, that is 25. 25. So if we put like that, the is that? We
Simple X and Y. Use simple X and Y. Here it's capital.
okay, wait, caps, I'll remove this x and remove this y. Ah, yes, yes. So that's how it is. Likewise, we can draw. See, the center is anyway 0, 0. That's how it works. So
Yeah.
we can do those type of ones by using the graphing tool. That is done. Then the theory part, what we have, to find the equation of a circle, we let the coordinate will be xy, one coordinate, be any point on the circumference of a circle with the center they have given, that is AB. Then what they do, they just make this, they just create this right angle triangle. Here the R value comes this distance in between the point P and the point C. That's how normally we have that value. So using Pythagoras theorem on triangle, we can calculate CQK squared plus QPK squared is equals to CPK squared. That means the R squared by substituting all these values. So here we have the x value, x minus a. Here we have the x minus b value. This part is x minus b. This part is actually y minus b. This is y minus b, the difference in between these two. And here we have x minus a as well. So by substituting these values to this given triangle, then we can have the equation, that is this equation of a circle, that is x minus a k squared plus y minus b k squared is equals to r squared. So this is a completed square form. Completed square form. Again, equation of a circle in completed square form. That's what here we have. Okay, it's clear, right?
Okay.
Okay. Can you
Yes.
please explore 3.3 and the worked examples? Go through with the.
Okay. Done, teacher.
Done. Okay. So the entire worked examples are done. Now here, what do we have for the expanding equations? Anyway, earlier this one was the completed square form. Once we expand the entire equation like this, we will receive an equation in this format: x squared minus 2ax plus a squared plus y squared minus 2by plus b squared is equals to r squared. That's what here we have. And then we can rearrange all these terms according to this another form, that is x squared plus y squared minus 2ax. The x terms we can take together, and then y terms we can take together, and all the constants we can move together and equalize this into 0. That's what here we have. So then, when we write the equation of a circle in this form, we can note some important characteristics of the equation of a circle. For example, it can be the coefficient of x squared and y squared are equal, and also there is no xy terms as well. If we have xy terms, it won't be a circle actually. And also the degree of the x squared and the y squared terms, the degree of the x terms and the y terms should also be equals, because not the degree. Anyway,
The coefficient.
it would be x squared and y squared. No, the coefficients will be
Yeah.
same. If it's 2 nan 2x squared plus 2y squared tamai venne hamatissema, always the coefficients will be same. That's what here we have. So then we often write the expanded form of a circle as x squared plus y squared plus 2gx plus 2fi plus c is equals to 0. Um, so that is there. Then the r would be actually g squared plus f squared minus c ge square root එක තමයි we normally consider as the radius of the given circle. Now, this form is the general form. Ara isalla what we had was the completed square form. These are the two forms so far we have learned. Okay?
Okay.
Okay. Now, this one, there's nothing, no, anyway, x squared plus y squared plus 10x minus 8y minus 40 is equals to 0. Now, they are asking to make this as a completing squared one, to write this same equation in the form of completing squares. How we gonna write this?
Mm. So we can bring the x terms to x terms together and the y terms together and then kind of factorize them.
Yes.
Yeah, something like
Yes, that is then there's nothing new actually. Yeah, that is there. So this also done. Up to this point, everything is clear, right?
yeah.
Okay. Then it is useful to remember the three following right angle facts for circles as well. What are these? What are these things? First one is the angle in a semicircle. Semicircle is a right angle. So when it comes to quadrilaterals, when we learned about the quadrilaterals also, we are discussing these kind of things. So the angle in a semicircle is a right angle. Angle in a semicircle is a right angle. So the perpendicular from the center of a circle, the perpendicular from the center of a circle to a chord bisect the chord as well. So this is the center. This is the perpendicular form of the center of a circle to a chord. This is the chord. Chord bisect the chord. So from this line, this entire chord will be bisected. So here we have the tangent. If we draw a tangent to a circle at a point P, we at a normal point P on a circle, then is perpendicular to the radius at that point. So these two gradients also, if you calculate the gradients of this and also this, and then if you take the multiplication of these two gradients, then that is also equals to -1. That's what there we have. So here then, from these statements, we can conclude that if triangle ABC is right angled at B, then the points ABC lie on the circumference of a circle with AC as a diameter. So if this angle is 90 degrees, we can predict, not predict actually, we can say that all these 3 points lie on a circumference of a circle ABC with the diameter of AC. If the perpendicular bisector of a chord passes through the sector, මෙන්න මේ chord එක perpendicularly bisect කරන එක if it passes through the center, then again it will be like perpendicularly those two will be intersected. Then here we have if a radius and a line at a point P on the circumference are at right angles, then the line must be a tangent to the curve as well. If we draw a line from the center to this line, maybe first we don't know whether it's a tangent or not, then whatever
Yeah.
which at a point, then if these two intersect in perpendicularly, then we can say this is the tangent කියලා. That's what here we have for all these three. Okay? Is,
Okay.
is it fine? Okay, now
Yeah,
can
yeah.
we do the 3.13? Seems like it's, oh yeah. First do the 3.13 and then you can do the 17th question as well. Last question. What they have marked as practice කියලා. ඒ දෙක විතරක් කරා.
Okay. Teacher, I'm in the 17th question. Part A, I'm kind of confused.
Okay, so what they are saying, 17th, the design shown in made from 4 green circles and 1 orange circle. Okay, this is that no, 4 green circles and one orange circle. So the radius of each green circle is 1 unit. Radius of each green is 1 unit. Find the radius of the orange circle. Find the radius of the orange circle. That means if you directly draw like this, so directly draw like this. Now what will happen? The design shown in made of 4 green. The radius of each green circle is 1 unit. Find the radius of orange one. Give me 1 minute.
Okay.
So I'm also confusing how we gonna find out the middle Harini. Then Mettana we have the semicircle thing also. If we have the semicircle one and but even I also have a question. How we gonna find out the missing part here?
Hmm.
Find the radius of the orange circle. Radius means if we consider the radius of the orange circle means from here to here. Anyway, the got 2 plus something. 2 plus something how we gonna find out? Why divide this into two followings? The shown, okay, the previous question, the circle has radius 10. Okay, if we find out the points, how are we gonna say? The design shown is made from 4 green circles and 1 green. Okay. one room. What is there? Even though I'm also confusing how to find out the middle part here. How? Mm, mm, mm. Okay. Mm.
Part B also pretty much the same thing.
Huh?
I mean, part B is also pretty much the same thing. So I'm kind of
Yeah, but
confused
we
with the
also
purpose.
yes, yes. So we can do this one. See, this is easy. Okay, now I found. How we gonna say? See, if you can. So here we have the middle point. Here we have the middle point. Here we have the center. Here also we have the center. No? Then what we can do? We can draw this line like this. And once we draw this one, once we draw this one, how do we? No, once we. Okay, we can draw this. No. Okay, we can draw like this. Okay, what you have to do here is you have to first find out the center points of all these ones and draw this. Yes, then you will be able to calculate this. එතකොට මෙතන ඉඳන් මෙතනට 1 centimeter, sorry, 1 unit, not 1 unit,
Yeah.
2
Yeah,
unit.
1 unit.
No, the rest.
Yeah.
Yeah, then
Yes.
this length is 2 units, this length also 2 units. හරිද?
Hmm.
එතකොට now here we have what we call the rectangle, no? A right angle නේ.
Yeah.
එතකොට we can find out the height, which means මෙතන ඉඳන් මෙතනට තියෙන distance එක. හරි? මෙතන ඉඳන් මෙතනට
Hmm.
තියෙන distance එක we can calculate it as 2 squared plus 2 squared ගේ square root එක. Okay, this amount is anyway 4. 4 plus 4, that is 8. 8 means 2 square root 2, no? එතකොට මේ 2 square
Yes.
root 2 means this whole part from here to here. ඒකෙන් half කියලා කියන්නේ මෙතන ඉඳන් මෙතනට.
Root 2. Yeah, root 2.
Root 2. Root 2 means from here to here. ඒ කියන්නේ මෙතන
Then
ඉඳන්
plus 1.
then plus 1. 1 plus root 2. That's how.
Okay, it's not hard.
Yeah. Now complete this entire thing.
Okay, teacher, done.
Okay, that is done. Okay, then it's clear, right? Okay, you can do the rest. That's fine. So we can start the next part from next day onwards. So you can complete up until 3.5, right? 3.5, up until 3.5, you can complete. Ah, wait. Shall I complete this part as well? Then you can leisurely complete the whole lesson. Yeah, yeah.
Yeah, just a little bit more.
Yes, so here we can have this is kind of a summary again. Problems involving intersections of lines and circles. So this part is in chapter 1. You learned that the points of intersection of a line and a curve can be found by solving their equation simultaneously. So then the intersection points come once we solve these two equations simultaneously. So you also learned that if the resulting equation is of the form, if we have the resulting equation as ax squared plus bx plus c is equals to 0, then b squared minus 4ac gives the information about the line and the curve. What it say? If the b squared minus 4ac is greater than 0, normally if it's a equation of a quadratic one now, then we know that there should be two distinct real roots. That means if it's the intersecting line and a parabola, then we should have two distinct points as well, where it intersects line and the curve. If it's equals to 0, that means we have two equal roots. No, if we have two equal roots means that means we have one point of two equal roots means there we have one point of intersection line is a tangent as well. So here we have less than 0 means that is no real root. We have a complex root. That means there's no any points of intersection as well. That's what here we have.
Okay.
According to the equations, we can have the intersection points. If the line and the parabola intersects, then we can identify how many intersection points are there. We can decide. That's what here they have given. It's clear, right?
Yes.
Okay. Then you can try the 3.14 at home and also complete the rest of the exercises. That's it. So the third unit
Okay,
is
teacher.
so done. Then we have the fourth one. That's fine.
Yeah.
Okay. Then,
It's actually easy, the third
yeah,
unit.
it's actually easy. Yes. So that's it. Then see you next day. Bye.
Okay.
Bye.
Bye, teacher. Good night. Thank you.
Night.